Hi, to start today, I've got a little task for you. I want you to get a piece of A4 paper and draw a dot. When the A4 paper is in landscape position, draw it halfway across, the A4 paper in this direction, and 5 centimeters up from the bottom edge. So just pause the video and please do that. And don't just pretend you're doing it, actually have a go, because you get a nice result and it's great if you can see it yourself rather than just watch me demonstrate it. What we then do is take a bottom edge, just a point on the bottom edge, and fold it up so it is in line with your dots. So the edge is essentially just going to touch the dots. Make a strong crease and then open the paper back up again. And then essentially you're going to repeat that process. So just go along a little bit, just so you're trying to kind of get even spacing, and repeat the process. And then do this many times in many different spots, always using the bottom edge. Don't start doing the side edge, it's got to be the bottom, and that can include the point directly below the point that you've drawn. So pause the video, try this out. Right, I hope you're not disappointed. I hope you can see what's going on here. When you open it, well, when you sort of have all your creases, you should end up with something that looks a bit like this. The many creases actually form this kind of curve, which is known as a parabola. What we get is a lovely kind of symmetry going on, and this point here is actually called the focus. And there's something special about this. Let me do some blue. Something special about a parabola. If you have light coming, for example, then it will necessarily reflect onto the focus. Maybe another bit going down here, and it will go here. A bit of light here, and it will come back up. Essentially, you get all these reflection lines that go towards the focus. And this has really useful applications. For example, here is a three-dimensional, essentially a parabola, paraboloid, I believe it's called. And the light is coming in from stars, I don't know, millions of miles away. They hit the paraboloid and they direct up to this focus, and there we have a way of sort of measuring or gaining this information, absorbing the light. And the same would go for a satellite dish on your house. There's also other applications of it as well, but it's quite a nice little start, and we'll see how this actually links in to the lesson. Well done if you've given that a go. I hope you're happy and you've got your parabola, and you can even draw these lines of reflection to help complete it. Even the one down here will go like that. Today we're going to look at factorising quadratics, an introduction, and it's also involved sketching quadratics because it's a nice result that follows from it. So we're going to try and sketch some algebraic functions labelling key features, and here's the checklist for how we're going to do that. So when I say happy or sad, I'm referring to a quadratic, and I've just realised I've not defined what that is yet. It's a function involving x squared and no higher power. There will be ones later on with an x cubed in. They're not quadratics, they will be cubics. So x squared is the highest power. That's something to be aware of. Factorising is when you're putting it into double brackets, and sketching is when you then, as a result of that, manage to not plot the graph, but just put a rough sketch of what's going on with any key features. But it will make more sense when I've done one. So the first thing to say is there are essentially two types of quadratic. They can either look like this, or they can look like this. These ones we call happy, just because they're they look like a smiley face, and these ones are sad. The happy ones have x squared as their as a thing, or 2x squared or whatever, but a positive. So let me put a positive there. And the sad ones have a negative. You could even say that the plus x squared ones are positive, so they're happy, and the minus x ones, well, they're negative, so they are sad. So if we look at this one here, we can see that we've got an x squared by itself. It's a happy quadratic. I'm just going to write that for step 1. Meanwhile, the y-intercept is a bit like when you're doing it for y equals mx plus c. It's essentially when x is equal to 0. I should write that there. And here, it's going to be minus 4. It's just a number by itself. Now I need to factorize it. This lesson really assumes that you can factorize two numbers that multiply together to give minus 4 and add to give minus 3. It's got to be x minus 4, x plus 1. That's the only thing that can be. We factorized it. Now we need to find the roots. So essentially, we solve y is equal to 0. And it's either that this one is positive, or this one, 0, or this one is 0. So the roots, we call them the roots when y is equal to 0. It's going to be x equals 4 or minus 1. We take the negative of here, but essentially I've solved x minus 4 equals 0 or x plus 1 equals 0. Now, it's a little tricky bit. Find the turning point. Okay, before I do that, I think a good idea is to start a sketch off because it'll make more sense what I mean by a turning point. So here we go. Here's some axes. It's only a sketch, so it doesn't have to be exact. But we should really put the x in and the y in. Now we've got lots of useful information. We know that it goes through minus 4. That's the y-intercept. And we know that it goes through x equals 4 and y equals minus 1. And we know it's happy, but we don't know at the moment whether this is going to look like that, or maybe it goes down a bit further and then comes up. So the turning point can help, and it's actually the point in between minus 1 and 4. So there's a distance of 5 in between minus 1 and 4. So if I have that 2.5 and add it to minus 1 or subtract it from 4, I'm going to get to 1.5. So the turning point, I'm running out of space, but the turning point I'm going to write as TP. Is going to be x equals 1.5. And I can substitute that into my calculator. I've done everything without my calculator so far. I'm going to substitute it in 1.5 squared minus 4, and I get minus 6.25. That's going to be my y value that goes with it. Just to say again, I've substituted it into the original function. So I know it's going to be, say, down here. Because I've gone along 1.5, I've gone further than the minus 4, I've got the turning point. Now I can actually finish sketching the graph. It's going to come down, it's going to go through there, it's going to come back up, and it's going to look a bit like that. It should go through that point, so maybe I should have made it go through there. I'm just going to move it very slightly so it does. And we got our first sketch of a quadratic. The only thing to say, oh, and by the way, this is a parabola. So the thing I showed you before, I was talking about parabolas. That's what quadratics are. They are parabolas. So that's a key word to learn. And the line of symmetry, we saw on the previous, when you're making a parabola, that it is perfectly symmetrical. So the line of symmetry actually goes through the turning point. Here it is, that line of symmetry. Maybe let's have it going just through the graph part. And I just need to write down the equation of that line. It's a vertical line, so it's an x equals line. It goes through 1.5, so the line of symmetry is 1.5. And that is a really solid effort to sketch a quadratic. I've labelled my roots, I've labelled the y-intercept. I was just going to try, it's like, maybe I should have written it to the left. I might just do that. I've got the turning point, that's one of the trickiest bits. And then from that, I've got the line of symmetry. There we go, which I've written on. I could have maybe have just added a coordinate for the turning point here. All right, I'd like you to try one now. This one here, please. Pause the video, try this one out. So I'm going to go through it, but a bit quicker because I've taught the main idea. So the y-intercept this time is going to be 6, that number by itself. Oh yeah, and it's a happy quadratic. So factorize it. Y is going to equal x. Right, two numbers that times to give 6, add to give -5. They've got to both be negative. It's going to be x minus 2, x minus 3. So the roots are x equals 2 or 3. Start the sketch. Label these key points. We've got, we know it goes through 6. And then we know it goes through 2 and 3. I might be exaggerating it slightly. It doesn't have to be perfectly to scale. And then I'm going to have my turning point. I'm going to write that down here. It's actually going to be x equals 2.5. It's in between the roots. I guess you've got to trust me on that one, but we know it's symmetric, so it's got to be between the roots. Substitute 2.5 into your original equation or into your factorized one. You can do that instead. Sometimes that can be quicker. 0.5 times minus 0.5, it's going to be -1/4. I can already see it even without a calculator, or I can substitute it in. I've got the same thing. Y is equal to minus 0.25. So I see that I get this point here, and I'm just going to then write it in as a coordinate. And I'm essentially done with the sketch. I can just have it coming down like this. That is pretty good. Just got to get that line of symmetry in. There we go, the vertical line goes through the turning point, and it's going to be x equals 2.5. So you can see this lesson really moved on very quickly from just factorizing quadratics. We've done a lot more, but I hope you're happy with this so far. We've got more examples to come. Let's keep going. So here, slightly different ones. If you're really confident, go for it right now. Otherwise, watch on and I'll explain this one. The first one, because the first one is just a little bit, you have to be a bit careful. So first of all, first thing to say is that this is going to be a sad quadratic. There's a minus x squared. It's going to be going up like that. I mean, how do you know that? Well, I'm telling you, but if you plot quadratics, and you should have plotted some in the past, and you would see that. You'd see that the negative ones do that, and the positive ones do that. I suppose I can talk about it a little bit more. The x squared term is going to dominate when x gets big. So when x goes to infinity, for example, over here, the y is going to go to infinity. You can see that it's going to get big. Meanwhile, when x is 0, you're going to get, say, -4. So you can see it, it's going to have to come down at some point. When x gets big, but in the negative direction, a large negative number squared is also going to be really big. So hopefully it makes sense that it's going to come down and then back up. Meanwhile, if you've got a minus x squared, that just flips around. It's going to start at negative and go up and then come back down, just because I'm essentially switching everything around. Let's look at a large positive number. This bit's going to be negative. a large negative number, this bit's also going to be negative. So that is why it's going to be a sad quadratic. Where were we now? So we were talking about the y-intercept. That's the next thing to find. And that's going to be equal to 4. Now I'm going to factorize. You just got to remember your steps. Okay, don't forget about this. We've done this, and now we're factorizing, and then we're finding the roots. Okay, tricky one to factorize because there's a minus x squared in there. Good idea is to actually just take the minus out completely. Factorize out a minus. It becomes x squared minus 3x minus 4. Because now all I've got to do is factorize this expression by itself, and in fact it's just the one we had here. So it's x minus 4, x plus 1. And everything else is going to sort of follow in the same way. We're going to get roots. It doesn't matter that there's a negative there. Roots x equals 4 or minus 1. The turning point is still going to be between minus 4 and 1, so it's going to be 1.5. But before I do that, actually, let's start the sketch out. So I know that it's going to have a y-intercept of 4. It's got roots of 4 and minus 1. It's going to come up. The turning point is still going to be when x is 1.5. But this time it's just a negative what I had before, so it's going to be 6.25. And I can add that on. Maybe it's about here. Maybe it's a bit to the left. And I'm done. I just need to draw this sad quadratic in. And my sketch, like I know it's not to scale, but I should just try and make sure it does go through all the points. And it shouldn't have that little bit at the end, so I'll just get rid of that. The only final thing is to get this line of symmetry in. Okay, mine doesn't look very symmetrical. It's got to be said. I could have probably done a better job at that. And this line should be vertical, I think it is. So again, we're going to get x equals 1.5 as the line. So the only new piece of information here is that it's a sad quadratic, and we've got to be careful when factorizing, put a negative in. The rest falls out in the same way. Try this one yourselves, number 4. So step 1, sad quadratic. Step 2, y-intercepts. Oh, we need to be a bit careful because we really should write it in the form y equals minus x squared plus 3x plus 10. Because now we can see that the y-intercept is equal to 10. It's the number by itself. Now we're going to factorize it, and first of all we're going to take the minus out. So it's going to be minus x squared minus 3x minus 10. Which when I factorize it, it's going to be x minus 5, x plus 2. Roots x equals 5 and minus 1. Sorry, minus 2. That looks like a 1 there. Right, we've got to get the turning point, but let's start the sketch off. So I've got the y-intercept of 10. I've got the roots of minus 2 and 5. Turning point is going to be halfway between, so there's a distance of 7, so add on 3.5, it's going to be x equals 1.5. And then I can work out what y is by substituting that into either one of these. So I get minus 1.75. Just double checking. That doesn't make any sense, does it? The turning point, I must have made a mistake there. So sometimes you can put things in your calculator, but it doesn't make any sense. So you probably spotted that already. Let's just try it one more time. Oh, I think I just didn't. 1.5 is definitely correct. So minus 1.5 squared plus 3 times 1.5 plus 10. That makes more sense. 12.25 got out of that one. So I can draw my graph. I should be doing this color here. Okay, I'll draw the graph first actually, and then I'll put the turning point in. Okay, so well done if you got that. A sad quadratic, we've got the roots, got the turning points. We've just got to draw that line of symmetry in. Like so. And x, again, is 1.5. This is coincidental. All right, good, good, good. Here are two more to try. They're sort of special cases of the first one. I've got rid of the negatives. Make sure you can deal with these. So I'm going to talk through them. Both of these are happy quadratics. Got a y-intercept of 9, a y-intercept of minus 9. Factorising gives x minus 3 times x minus 3 in this case. They're actually the same. This is sometimes written as x minus 3 squared, so be aware of those. Meanwhile here, we have something known as the difference of two squares. It's y plus 3, y minus 3. Sorry, x plus 3, x minus 3. Because it is in the form a squared minus b squared. This is a classic difference of two squares. I'm going to write that down because just in case you've never seen it. So the roots, or the root in this case, is simply x equals 3. Whereas the roots here are x equals minus 3 or 3. There's 2 in this situation. We're well on our way to be able to sketch both of these, so I'm just going to start the sketch off. Put the points on, so we've got 9 and we've got 3, and that's it. Here we've got minus 9 and we've got minus 3 and 3. Right, what's going on with this one? Well, actually, the turning point, there's only one root. The turning point is going to be 3 itself. This is a special case because it's squared, it never becomes negative, and it's a quadratic. It just touches the axis. Let me try that one more time because it didn't look like it was touching. Okay, that's a little bit better. Still not happy with it. I'm going to move it down. Yeah, that's better. So it doesn't have 2 roots, it just has the 1 root. We get the turning point sort of immediately, to be honest. Turning point is going to be x equals 3, y equals 0. Meanwhile, over here, actually the point in between -3 and 3 is 0. So we again get the turning point. In some ways, these are easier. Sorry, my pen just stopped working throughout that. One more go. Okay, that's a good parabola, except maybe it came in a bit at the end. Try and make them as symmetrical as you can. Alright, that'll do. So we've got all the key things. We've got the turning points. I could label it if I wanted to. It's going to be 0, -9. And here we've got 3, 0 as a turning point. I mean, they're already labeled, to be fair. The only thing to put in is this line of symmetry at the end. Even though I did talk about right at the start about there being a focus and so forth, we don't need to worry about that. We just need to be able to get the line of symmetry. So the line of symmetry here is x equals 3, and the line of symmetry here is the y-axis, or x equals 0. So do add those. Okay, it's looking good. Lots of happy quadratics here. Okay, main thing to take away from today rather, is this is how we can sketch quadratics. You need to be able to factorize them. Actually, the main focus has been factorizing, so hopefully you've practiced that. But at an A level, another skill is to be able to sketch these graphs that will be expected, to know what they look like. So we've got these happy and sad ones. We know the difference. We can factorize, we can find the roots, we can find a turning point. One of the harder skills from today, I think, we'll look more at turning points in future lessons, and this line of symmetry that perfectly splits the parabola into 2, in theory. My sketches are not perfect, it's got to be said. We can do these ones, and we've got these 2 examples where you get 1 root where it just touches the axis. Of course, you could get the same, there's a sad quadratic, and a special case known as a difference of 2 squares. So that's the main bit, and that's what I want you to take away. I've got a little extension for you to try. Now this is actually essentially on the A-level syllabus to be able to sketch ones like this, but you will revisit it. So see it today, not as something you have to learn straight away, but an extension. Give them a go. They can factorize them. Okay, so I'm going to talk through them. The main thing to say is that this is no longer a quadratic. I've actually thrown these in slightly different. Neither of these are quadratics. This one is a cubic, and it is a positive cubic, so it will look a bit like this, or it might actually look like this. It might not go up and down. It's a positive cubic. I'll come to this one in a bit. I think this is the main focus. Now, I'm still going to get my y-intercept. Actually, it's a number by itself, which is just 0. So the y-intercept is 0. Actually, it's not that bad. And now I'm going to try and factorize this. Well, I can actually factorize out an x. That's the first thing you do when you've got a common factor, which leaves me x squared minus 1. And suddenly I've got a quadratic that I can also factorize. This is another difference of 2 squares. It's x plus 1, x minus 1. I've managed to factorize this cubic. It all works in the same way. The roots are going to be x equals 0. Don't forget I get a root here. Minus 1 from this one, or 1. And actually the turning points we're not going to be looking at. There are turning points on the graph, which we'll see in a minute, but we haven't learned how to calculate them yet, which you will do. So there we go. It's going to go through 0, minus 1, and 1. And it must be, it's going to come up from minus infinity, come back down, and then go back up again. That is our cubic. We get turning points here, but they're actually not necessarily halfway between the coordinates. So that's it. I mean, in many ways it's more difficult. In some ways it's a bit easier if you know what a positive cubic looks like. A negative cubic, by the way, looks like that. That's when you got minus x squared, but you will study cubics in more detail. Like I said, this was an extension. And finally, we've got a quartic here to solve. I'm not going to talk about the shape of those quite yet. We'll come to that. So the first thing to say is that the y-intercept is equal to 4. And now I can factorize this. Actually, you can factorize this in terms of x squared. If you imagined that I had x squared minus 5x plus 4, that one's not too bad to factorize. We get x minus 4, x minus 1. So if I just replace my x squared by x to the 4 and x by x squared, I can actually factorize for x. It's going to be x squared minus 4, x squared minus 1. If you didn't see that, then hopefully that makes sense now. If you expand it out, it will work. And we can factorize it still further. This first one is a difference of two squares. There's x plus 2, x minus 2. And the second one is a difference of two squares as well. It's x plus 1. I'm running out of room. X minus 1. That should go there. So my roots are going to be x equals minus 2, 2, minus 1, 1. And we'll forget about the turning points, but we can still get the shape. Apologies, I'm on a bit of slowdown today. Right, we can try and make sense of this in a minute. So we know that it goes through 4. We know it goes through minus 2. We know it goes through minus 1. We know it goes through 1. And we know it goes through 2. Now when x is really big, x to the 4 will be really big, and y will actually get really big as well. So actually this kind of starts out a bit like a quadratic. It comes down from infinity down here. And then we know it goes through 2, but it's got to come back and go up through 1. So actually it's going to look like this. And this is perhaps the first quartic you've ever seen. We actually get a W. So instead of it being a smiley quadratic, we get like a kind of a weird looking, that's a bit harsh, just a person that's smiling in a interesting way, let's say. So this was my extension, but I hope that makes sense. And you can now, I don't know what this would be, how you would be. Anyway, oh, it was a positive positive cubic, wasn't it? So positive cubics look like this. There we have it. These are the extensions. Don't stress about those. Make sure you understand sketching quadratics and turning points and lines of symmetry, and you can factorize. That is the main focus. Brilliant effort. Hope this makes sense. Well done.